viewers, welcome to the Physics Mind. Today we will be looking at the velocity time graph. First of all, what is velocity time graph? The velocity time graph is a graph of velocity plotted against time. It's a graph that shows the relationship between the velocity of a moving body and the time taken for the body to move with that velocity. Okay, so basically there are two uses of this graph. Now, firstly, it is used for finding the total distance covered by a moving body. And secondly, we can also use the graph to deduce or obtain the acceleration or retardation of the moving body. Okay, so before we dive into the different examples under this velocity time graph, there are basically four graph formats we need to know before we can perfectly understand the velocity time graph. Now, the first graph we're going to be looking at is when the body is accelerating from rest. The first one is accelerating from rest. So when the body is accelerating from rest, now this is the format of the graph. This is a graph of velocity in meters per second against time in seconds. So when the body is accelerating from rest, it means that the initial velocity is 0. So this is the graph or the format of the graph. Let's say this point is point A. So the acceleration of the body is the same thing as the slope or the gradient of line OA. That gives us the acceleration. Well, anytime a body is accelerating from rest, then this becomes the format of the graph. Okay, so secondly, when the body is accelerating but not from rest, that means it's actually starting with an initial velocity that is not 0. So let's say accelerating from an initial velocity u. This becomes the format of the graph. This is our velocity in meters per second, and this is our time in seconds. So here is the origin, but the graph is not actually starting from the origin, but it's going to be starting from an initial velocity. Let's call this v1, and then until it attains a final velocity, which is what? v2. Okay, so the gradient or the slope of this line represents the what? The acceleration of the body. So anytime a body is starting from an initial velocity, then this becomes the what? The format of the graph. Remember, at this point here, it will be that initial velocity. Okay, so the third graph format we need to know is when the body is moving with a constant velocity. Okay, constant velocity. So we call it the constant velocity or the uniform acceleration. Sorry, uniform velocity, not uniform acceleration. With the constant velocity or the uniform velocity. Okay, so this becomes the graph format. These are velocity in meters per second, and these are time in seconds. So if the body is moving with a constant velocity, it means that the velocity is constant or is fixed. It does not change. So this becomes the graph format. So it means the acceleration along this path becomes what? 0, because velocity is not changing. Remember that acceleration is the rate of change of what? Of velocity with time. So if velocity does not change, rather it's constant or is fixed, then acceleration becomes 0. So the acceleration along this path is 0. So anytime a body is moving with a constant velocity or with a uniform velocity, then this becomes the graph format. Okay, so the last format we are going to be looking at is when the body is decelerating uniformly. When the body is decelerating uniformly. So these are velocity in meters per second, and these are time in seconds. Okay, so when the body is decelerating, Now this becomes the graph format. That means that the acceleration is actually, or the velocity of the body is what? Is gradually reducing, and finally becomes what? Zero. So this becomes the graph format. And the gradient of this line represents the what? The deceleration or the retardation of the body. Okay, so these are the four graph formats we will be looking at. Okay, so let's dive into the examples. Okay, so we have an example here which says that a car starts from rest with a uniform acceleration until it reaches a velocity of 30 meters per second after 5 seconds. It travels with a uniform velocity for 15 seconds and then brought to rest with a uniform retardation in 10 seconds. Calculate the one, acceleration of the car. Secondly, the retardation. Thirdly, the distance covered after 5 seconds. And lastly, the total distance covered. So before we solve this example, the first thing we need to do is to draw or to sketch the velocity time graph for the motion. So we need to sketch the velocity time graph for the motion. Okay, so sketching the velocity time graph. Remember, it is a graph of velocity against time. So this is our velocity in meters per second, and this is our time in seconds. Okay, so we are told that a car starts from rest with a uniform acceleration until it reaches a velocity of 30 meters per second. So it means that the acceleration there is what? Is uniform. That is a uniform acceleration. That means the body, and also the body starts from rest. So since it's starting from rest, it means that the body starts from moving from this point and then upward. Remember, start acceleration from rest. And then we are told that until it reaches a velocity of 30 meters per second. That means that the velocity keeps increasing until it reaches what? 30 meters per second. So this is 30 meters per second. Okay, so after 5 seconds, it means that the time interval for this movement or for this motion is 5 seconds. So this is 5. Remember, the time is already in seconds. This is 30. We don't need to write the meter per second. So this is just 30. That covers already. Okay, so we are told that it travels with a uniform velocity for 15 seconds. Uniform velocity. Remember, uniform velocity is the same thing as what? Constant velocity. That means that the velocity at this point remains what? Constant. It does not change. It didn't increase, neither did it what? Reduce. Rather, is constant for how many seconds? For 15 seconds. So this velocity remains constant at this point for 15 seconds. So it means that earlier on it was 5 and then the constant velocity is for 15 seconds. So when we add them up, that will give us what? 5 plus 15, that is what? 20 seconds. Okay, and then we are told that, and it is then brought to rest with a uniform retardation in 10 seconds. That means that the body retarded uniformly. That means it comes to rest. So this is for uniform retardation, and we are told that the movement lasted for 10 seconds. So this is 20 seconds already. So plus a 10, that will give us what? 30 seconds. So this gives us that. Okay, so by this we sketch the velocity time graph for the motion. So, but before we look, be able to calculate other things, we need to what? To label the graph. Okay, so let's call this point point O. Let's call this point A. This is point B. This point, let's call it C. This is D, and this is a point E. Okay, so we sketch the velocity time graph for the motion of the body. So we are asked to calculate the acceleration of the car. How do we obtain the acceleration of the car? Of course, we know that the acceleration of the car is the gradient of line OA, because it is only along OA that the body was accelerating. So that is where we'll get our acceleration. So firstly, acceleration is equal to the slope or the gradient of line OA. That gives us the what? The acceleration of the car. And how do we obtain that acceleration now? Okay, so the acceleration is going to become the gradient of this line OA, which is the change in velocity with respect to time, which is v minus u over time. And the final velocity here is what? Is 30. Initial velocity is what? Is 0. The body started from 0. So minus 0 over the time interval, which is 5 minus 0, or just 5. So giving us 30 divided by 5, which will be equal to 30 divided by 5, which is 6. So that gives us 6 meters per second square. So that gives us the acceleration of the car. Now, secondly, we are asked to find the retardation. Retardation. So how do we obtain the retardation? Now, retardation is going to be obtained along line BE. That is where the body is retarding uniformly, when the body is decelerating uniformly. That is where we obtain the retardation or the deceleration of the body. And it's similarly going to be equal to the slope or the gradient of line BE. So, which will be equal to the same thing. Now, what you also need to know about the retardation is also called the negative acceleration, because it is always what? Negative. So, we denote it by A bar to differentiate it from what? From that of the normal acceleration. So, that is still going to give us V minus C over T, because it is also an acceleration, but what? Negative. So, our final velocity in this case, now remember the body starts moving with an initial velocity of 30 meters per second. And then it keeps reducing until it finally comes to what? To rest, where the velocity there is what? Is 0. So it means that the final velocity along this line BE is what? 0, because the body comes to rest. So we have 0 minus the initial velocity. It started from what? From this point, which is 30 meters per second. So we have 0 minus 30 over the time interval for the body to decelerate. Now from 20 to 30, that is 10, or which is 30 minus 20, that will give us the time interval. So it is over 10. So giving us minus 30 over 10. So our retardation becomes minus 30 divided by 10, which is minus 3 meters per second square. So this becomes the retardation of the body. Okay, so thirdly, we are asked to find the distance covered after 5 seconds. Remember, one of the use of the velocity time graph also is to obtain the distance covered. So for us to obtain the distance covered, okay, so distance covered, but not the entire distance. In this case, we are asked to find the distance covered just after what? 5 seconds. That means that the distance covered by the body from this point where it started and then when the time is just what? 5 seconds. So we are finding the distance here. Okay, so for us to obtain the distance, the area under the velocity time graph denotes the distance covered. The area under the graph denotes the distance covered. So what do you mean by that? Okay, so along this part, OA, when the body was moving uniformly, now when you look at the shape, we are having a what? a triangle. Let's call this x. Okay, so if we call this x, so you will believe with me that along OA, the shape or the plane figure we are having there is a what? It's a triangle. So it means if we can find the area of this triangle, that will denote the what? The total distance covered by the body when it was accelerating uniformly, or when the time was just what? 5 seconds. Based on what we have to find the time, the distance covered after just 5 seconds. So when the time is 5, the area we have there is a what? Or the shape we have there is a what? It's a triangle. If the question says we should find the time taken after, okay, for instance, find the total distance covered after 20 seconds. Now we know that we actually calculated the distance from this point down to this point. But then from this point to this point, we actually have two shapes. This first part, which is the triangle, and then this other second part, when it was moving with a constant velocity, let's call this y. So you believe with me that y is a what? Is a square. So for us to find the distance here, that will give us the area of the square. So when we find the area of this triangle and the area of this square, we add them up. That will give us the what? The total distance covered after 20 seconds. If the question says find the total distance, then we also have to add it up here. And this other, when the body is moving with a uniform deceleration, let's call it z, for instance. So that is also a what? Is also a triangle. So since the triangle, we also use the area of a triangle to find the what? The area. So when we are done with that, we have to add the three of them up. That will give us the what? The area of the total body, or the area or the total distance covered by the body. Okay, but for now, we are only interested in finding the area or the distance covered after just 5 seconds, which is also a triangle. So for us to find that, okay, so let's clean this up. Okay, so to find the total distance covered after 5 seconds, so let's write the distance covered after 5 seconds. Okay, so the total distance covered after 5 seconds, let's call it S. Since we call it X here, let's call it X. And X now will be equal to the area of this triangle, we said, of triangle OAC. Okay, so the distance covered after 5 seconds is equal to the area of triangle OAC. So the distance will be equal to, and the formula for the area of a triangle we know is a half base times height. So that will give us 1 over 2. Now the base in this triangle is OC. This OC is the base. So half OC times the height of the triangle, which is what? AC. So times AC. So X becomes 1 over 2 multiplied by OC, which is what? 5, times AC, which is what? 30. Okay, so X now becomes 2 here, 1, 2 here, 15. So we have 1 times 5 times 15, that is 5 times 15, giving us 5 times 15, which is equals 75. So we have 75 meters. So that becomes the area or the distance covered by the body after 5 seconds. Okay, so lastly, we're asked to find the total distance covered by the body. So for us to find the total distance, it means we also need to find the area of this square and the area of this other triangle. Then we add the three of them up, since it is the whole journey that we are looking for the total distance. So that means I'll have to also find the area here. So let's call this y, and let's call this Z. Okay, so we have distance y, and y is actually a square, so it's going to become the area of square ABCD. So that is the square ABCD. So y becomes, now the formula for the area of a square is length times breadth. So in this case, we're going to be having CD multiplied by either AC or BD is still the same thing. Okay, so that will give us, and our CD is the interval here, which is 20 minus 5, which is equal to 15. So it means CD here is 15 times our AC, which is what? 30. So we have times 30. So our Y now becomes 15 times 30. So 15 times 30, that gives us 450 meters. Okay, so we also need to find the area Z. Okay, so let's use this space here to find the area Z. So Z is going to become the area of triangle. This is another triangle. So area of triangle DEB or BDE is the same thing. Area of triangle BDE. And Z will be equal to area of a triangle we know is half base times height. And the base in this case is DE. So half times DE multiplied by the height, which is what? BD. Okay? So Z now becomes half times DE, which is the interval here. We have 20 here, we have 30. So the interval is 10. 30 minus 20, that gives us 10 times BD. And the BD is the same thing as AC, which is what? 30. So half times 30. Okay, so Z now becomes 2 here, 1, 2 here, 5. So we have 5 times 30, which is equals to 5 times 30, which is 150. So we have 150 meters. Okay, so we have found the what? The respective distance for x, y, and z. So it means that the total distance is going to become x plus y plus z. That gives us the total distance covered. So write the total distance is equal to x plus y plus z, which will be equal to our x. We have found it to be 75. So we have 75 plus our y, which is 450, plus our z, which is 150. So we'll add them up. We have 75 plus 450 plus 150. That gives us 675 meters. So this gives us the total distance covered by the body. Alternatively, we can also calculate the total distance covered by the body without actually finding the respective what? Distance, because I notice this is very long. This is a long process. So you can actually get the total distance at a time without having to find the respective distances covered by the body. Okay, so in this case, we will have to calculate the area of the entire trapezium. Remember that the entire shape or the graph is actually a trapezium. So for us to obtain the total distance covered by the body, we will have to evaluate the area of this trapezium. Trapezium what? O, A, B, E. So we'll obtain the area of this trapezium. That will give us the total distance covered by the body throughout the journey without having to find the respective distance. So let's look at that alternative method to see if we are still going to obtain 675 75 meters. So to obtain the total distance covered by the body through this alternative method, which we said is equal to total distance covered, let's call it S, is equal to the area of trapezium, not trapezium, OABE. So that will give us the total distance covered. Okay, so the next thing is, what is the formula for calculating the area of a trapezium? Now, a trapezium, we know the formula is half A into A plus B multiplied by height. That is the formula of a trapezium. Half into A plus B multiplied by height, where A and B are the parallel sides of the trapezium. Remember, a trapezium always have two parallel sides. So you need to identify the parallel side and then multiply it by the height of the trapezium, or in some cases, you multiply it by the base of the trapezium, depending on which one of them is a parallel side. Okay, so in this case, we have half into the parallel sides, which are A and B. So let's look at our graph. What are the parallel sides? So our parallel sides are actually AB and OE. So we have AB plus OE. These are the parallel sides. So multiply by the height. So the height is either AC or BD. They are all the same. Okay, so that will give us the total area of the trapezium. So our total distance becomes half into our AB. So we're looking for AB, which is the same thing as CD. So this interval here is the same thing as AB. So CD, the interval there is what? 15. That is 20 minus 5. That gives us 15. So our AB is 15 plus OE, from O to E, which is what? 30. So 15 plus 30 multiplied by the height, which we say AC or BD. So AC is what? 30. So multiplied by 30. Okay, so that will give us 1 over 2 into 15 plus 30, which is 45. Now multiplied by 30. So 2 here, 1, 2 here, 15. So our distance becomes 45 times 15. So 45 times 15, 45 times 15, which is equals 675 meters, which is the same with what we have earlier, where we add the what? The respective what? Distances or areas of the different shapes. All right, thanks for watching. Please make sure you like and subscribe to my channel to get more videos like this. Bye.